All right, guys, in this video, we're going to talk about some free response questions that use accumulation functions and definite integrals in some context. So this first one, I think, is a little bit easier. I think the second one that we're about to do is really challenging. But this just takes time. It takes practice. It takes rethinking about these questions. They take a while. So this first example, I think, was off of 2010. It was number 2, but it might not have been 2010. Anyways, this is an actual free response question at some point. It says, a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries into a special box between noon, that's when time was 0, to 8 p.m. when time t is 8. The number of entries in the box t hours after noon is modeled by a differentiable equation, E. So notice E represents a total. It's not a rate. Values of E of t in hundreds of entries. Anytime it tells you like in hundreds of entries or thousands of units or whatever, I would kind of underline that. So when I have my answer, I kind of remember to take that into account. At various times of t are shown. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. So what this is telling us is estimate E prime of 6. So E prime of 6 is approximately, I would use this numbers, average rate of change. It would be E of 7 minus E of 5 over 7 minus 5. Remember, I use the t numbers right around what I'm trying to approximate. So 6 is right in between 5 and 7. E of 7 is 21 minus 13 over 2. It's calculator active, so I think they want you to actually get a number. On top, that would be 8 over 2, so this would be 4. And then I'm going to write hundreds of entries. 400 entries per hour because we estimated a rate. So the rate would be hundreds of entries per hour. All right, I think that's it for that one. Part B, use a trapezoidal sum with 4 subintervals given by the table to approximate this value. So again, anytime they tell me to approximate something, I'm going to go ahead and write that something that I'm approximating. Right away, I'm going to put that approximation symbol. Okay, now I have to remember, trapezoids, area of a trapezoid is 1/2, base 1 plus base 2, you got to memorize that, times the height. And you have to memorize that for questions like this. So this would be for 4 subintervals. Now I've got to remember which one's the base, which one's the height. The height, so if I have 0, 0, and 2, 4, and 5, 13, the heights are going to be your bases. The width of the trapezoid is going to be not the width of the trapezoid, the heights are going to be the widths. I might have said this all the way wrong. Okay, the bases of the trapezoid are going to be your y values. And then the height is going to be the distance in between the two x numbers. So this would be 1/2. Actually, there's an extra 1/8. 1/8 of all of this. So I'm finding the area bounded by the curve using trapezoid approximations. That 1/2 is just extra out in front. Okay, so this would be I think I said 1/8. 1/8 out in front because it's going to wind up being the average value. Base 1 is 0, base 2 is 4, and the height is the distance between the two bases, the change in t, plus 1/2. Now I use these two. Base 1 is 4, base 2 is 13. The height is the distance between the two bases, plus 1/2. And you might have also put the 1/2 out in front. Factored out a 1/2 all here, it'd be a little less writing. Base 1 is 13 plus 21 times the distance in between the two plus 1/2. Base 1 is 21 plus 23. Distance in between the two would be 1. Close bracket. And I probably just type this into my calculator. But you could also leave it like this. If I type this into my calculator, I would get that 1/8 integral from 0 to 8 e of t dt. Since I have a calculator, I can get the number. Is approximately 10.6875. So I'd say 10.688. This would be hundreds of entries. So the meaning, because the second part says, what is the meaning of this? And whenever I see that fraction out in front, and it just happens to be whatever the limits of integration, the difference of those, so 8 minus 0 would just be 8, that means it's the average value of whatever that unit is. So I would say 1/8, 0 to 8, e of t dt represents this would be the exact, right? I don't have to say approximate because I'm saying just in this terms, this would be the average value, or instead of saying average value, the average number of entries, and I might say in hundreds. And this is on the interval from t equals 0 to t equals 8. So if it asks me, if I say it like that, I think we're going to get full credit. If we actually got the number, we could say it's approximately this, but I think when it says what is this, that's the exact number. We use trapezoidal sums to approximate the value, but this is the actual number, the exact number. We don't know what it is exactly, but that's what it would represent. All right, part C. At 8 p.m., volunteers begin processing the entries. So this table is just how many hundreds of entries. So that means there's 2,300, right? 2,300 entries in the box after the 8 hours. So 2,600 people wanted to name the new baby elephant. I guess that seems reasonable. I have no idea. But at 8 o'clock, they begin to process the entries. So they're like reading what they are, tallying them up, I guess just looking at them. But they process the entries at a rate modeled by this function. And so this is a rate in hundreds of entries per hour from 8 to 12. So from 8 to midnight, right? So according to the model, how many entries have not yet been processed by midnight? All right, so if I'm thinking about this, in the box at 8 o'clock, there are 2,300 entries. I'm going to keep it 23, though. I'm going to put in the problem because this is in terms of hundreds of entries. But then they begin to process them. So they're pulling the entries out, they're reading them, they're tallying them up, whatever they're doing. So to find the how many entries have not yet been processed by midnight, I start with 2,300 and I subtract the integral from 8 to 12 of that p function that they gave us, the rate, right? And what this would give us, we would find this in the calculator. This can be done in the calculator. It's calculator active. So press math. I think it's number 9. I always got to double check. Math, number 9. Your limits of integration are 8 to 12. And then plug in this function. But instead of t, you plug in x's. So I would do 23 minus that, and I get 7. And that's just the answer. So 7, but it's in hundreds. So entries have not yet been processed. I don't know how to spell processed. Processed by midnight. So I guess they keep going after that or the next day. So there's 2,300 entries in the box. At 8 o'clock, they start processing them. And the total amount processed gives us out of this. So I do 23 minus the total been processed. they're left with 700 entries that have not been processed. All right. According to the model from part C, at what time were the entries being processed most quickly? So this is a tricky way to say a candidate test, right? The most quickly. So quickly is kind of like a rate, right? So what we need to do here is find the absolute maximum of were they being processed, right? Does that have anything to do with E? No. It's just find the absolute maximum, or find when the rate that they were being processed the fastest. When was that the most? And I would use a calculator for this. This is calculator active, so in class we'll do this and I'll show you. But what you would do is you would graph P prime, or the derivative. So P, oh, it all missed, all went away. P of T is equal to T cubed minus 30T squared plus 298T minus, so I need to find the derivative. P prime of T is equal to 3T squared minus 60T plus 298. And I would graph this. And what I'm trying to do is find where is the derivative equal to 0. And I would use my calculator, and I think I find that the derivative is equal to 0. It crosses the x-axis at 9.184. And the way I can do that, I'm going to walk you through this. I'm just going to do it in my calculator just so I know I'm saying the right thing. So I'm typing 3x squared into y equals minus 60x plus 298. When I graph it, I need to make sure that I can see where y is 12 at least. So I change my window, make the x max like 20. And if I'm looking at my graph, it's a parabola, right? It's parabola. And it crosses the x-axis at 9.184 and 10.816. And I would do that by pressing second, trace, and I could find the zeros, which is number 2. So if you have your own calculator, you can go through and do that, and you can find those 2 numbers. But my candidates, there are 4 candidates. It would be the endpoints. So I started at 0 and ended at midnight. No, I didn't start at 0. I started at 8, right? Didn't start processing until 8. 9.184, 10.816. And this is calculator active, so I can just plug in x equals 8 for P, and I would get 0. And then I would plug in 12, and I got 8. I plugged in 9.184 and got 5.0887. Plugged in the 10 number, I got 2.9113. So it says, at what time are the entries being processed the most quickly? So at 12. When T equals 12, the number or the rate is 8. That's the highest. So it's at T equals 12. That would be my answer. At midnight. All right, I'm going to break this up into 2 videos just to make sure it doesn't mess up the recording. So thanks for watching. And if you have any questions, I'll see you. Ask me next time I see you in class. Bye.